Assalamualaikum and good day. Today we try to continue from the lecture 4 about the still in the uh, wave, but in this part maybe we try to uh, touch about the reception, silencer and barrier. So in the lecture 4 maybe the lecture talking about the how wave come from, the sources come from, and then wave we try to uh, barrier to the medium. So for example like solid and fluid, and then we try to calculate, how much amount of the wave can be reflected and then also be transmitted, and then absorbed. So today I would like to concentrate or focus on the material or system can absorb, the dead wave, from the sound, or from the noise. So we try to touch about that. How the system can consider as absorber. So before we go to the introduce, the system, but we should be define the definition first about silencers. Silencer is a muffler, or silencer is a device used in the flow duct to prevent sound from reaching the openings of the duct and radiating as far field noise. So anything the system, we use to absorb the noise, we can call the silencer. So in this case, because we try to implement in the HVAC system, so the silencer will be used in the duct system, to reduce the noise, from the system. So reactive silencers is reflect sound back toward to the source. So what the response, So actually, when the source of the noise, we can call this is a action, and then from this action will be create the reaction. So reaction from the silencer, what they do is to reflect the sound back toward to the source. So actually not to reflect that only, but also can be absorbed, of the material. So and material itself have the capable to absorb the vibrate, and then the vibrate will be uh, not transmit, to the uh, other medium, solid or the fluid, And then absorptive silencer is silencer attenuate sound using absorbing material. So we have two system here in the silencer, uh, bo- both reactive and silencers, and then also absorptive, silencer. So absorptive silencer, we focus on the capable of material, to absorb the noise. Absorptive silencer. We go to absorptive silencer. So like I mentioned before, the silencer is divided by two way, to reflected and absorptive. So we go to absorptive silencer. To use a sound absorbing material in which sound energy is converted into heat mainly by a viscous process. So actually we can convert, this wave, into the heat. It's not only for the noise, we can convert to heat. Much energy, other energy also uh, we can convert to heat. So for example, also noise. Maybe from mechanical also, electrical also, we can convert into the heat. Typical sound absorbing material use are rock wool, glass wool, and plastic foam. So actually in the muffler itself, yeah, divide in the certain absorptive material. So maybe we can propose by the fibrous material. So fibrous material also have several optional we can choose. So in the market we can use the wool, yeah, we can use a glass fiber, or maybe we can use the aramid fiber, anything based on the fibrous material. Maybe in the future, maybe we can propose the natural fiber, maybe, yeah, because we can try, yeah, to as in the lab, maybe we by during the time and research, and then maybe we come out with the same performance with the commercial fiber, so we can replace by the nature of fiber. To force, yeah, the last bullet is talking about the force. To force the exhaust flow through the absorbing material will create a large pressure drop, so the material is usually placed concentrically around the main exhaust pipe. So because the sound is maybe will be concentrate on the end of the pipeline or pump system, yeah. So maybe we can absorb, yeah, the noise, yeah, and at the end of the piping system. Maybe we can introduce in the duct system, maybe around when the duct system will be of around the final, yeah, of the delivering system. So maybe we can choose the position around the exhaust, yeah, of the duct system. And then not only the duct system, we can also absorb in the maybe in the industry, yeah, itself, yeah, like the exhaust of the uh, ignition system, yeah. Okay. Okay, this one is called structure of the silencer with the exhaustive system. Yeah, so we can see where is the put in the duct system or the piping system. Yeah, anything. Maybe if you realize, yeah, in same thing like the exhaust system in the vehicle, they have also the hole in the piping to uh, allow the gas, yeah, to go through from the piping to the outside system of the piping, and then will be absorbed by the silencer system. So you can see the structure is the will be constructed by fiber system, and then the other absorptive material, you can choose. Yeah. So here they will construct by steel wool, and then another one is a mineral wool. Yeah. And then before that they have a hole to allow the gas, to go through, and then uh, absorbed by the material absorptive. Yeah. So the design is based on the distribution of noise, yeah, in the hole, from the hole, and then will be distributed. Yeah. So they describe the distribution with the uh, uh, system, yeah, mathematical calculation, yeah, and then they try to create the equation, and then they try to calculate, yeah, how much can absorb. So we go to reactive silencer. The other physical principle used is the reflection of sound, which caused by area change or use of different kind of acoustically resonator. So actually, this one already I mentioned, in the previous class. They will create the reflected by using geometry. Yeah, and maybe this one is will be used on the room, yeah, in the application, and then they will reflect to the wave, and then they will be go to the outside the environment, and then uh, we can direct this wave to the other way. Yeah, these types of muffler are called reactive. Yeah. So reactive silencer, you can see in the figure. So they have you see. So it's not direction is directly using, yeah, maybe by straight piping system or duct system. Yeah? So they use uh, like the junction, and then this junction, during the junction they create the one system to reflect the sound or the what we call a noise, and then they reflect and then back again from to the source. So different type of resonator in the typical reactive automobile, yeah, silencer. You can see maybe yeah, you can recognize, in the car system, vehicle system. It's not like the motorcycle system. So you can see on the bottom of the piping exhaust system. So you will see there's the reactive silencer, from the vehicle. You can recognize maybe like box system, in the exhaust system. So you exactly they put under the vehicle. So this one is a system by implement the reactive silencer. So in the reactive silencer, you can design by several system. So once you implement, you can confirm, make sure the sound or noise will be reduced, so by the reflected. So if this one sometime they already make a corrosion, and then make the hole in the reactive silencer, and then will be create the big noise, for vehicle. You can recognize, for this condition. Sometimes the silencer you need to replace by new one because already corrosion. So the system maybe reflect by not only straight piping system. They will try to get the reflected inside the system, and then the sound will be re, reflect back to the source way, source direction. Okay, in the industry, you can see from the figure, actually too much silencer here. As you can see in the exhaust system, too much here of the silencer. You can see every piping or exhaust piping, every exhaust piping have one system, like the biggest compared the piping or the tower system, and then this one is actually for the reduce the noise, in the industry. So you can see how they develop or construct the silencer for the industry application. So biggest than the person, you can see, and then they put the exhaust system. Okay, this one what I mentioned in the previous slide, with the reactive system, so you can see how to piping inside of the uh, reflected, silencer. So as you can see, it's not direct piping, but they try to create, here one system, and then they will absorb inside, yeah, by create the many hole here, and then other hole is to transmit, yeah, uh, the exhaust system. So they try to absorb here first, so you can see direction, maybe direction from the exhaust system from this way, and then they try to make the sound reflected inside here, and then another is to uh, transmit, yeah, the exhaust system, yeah, by create the another side, yeah, of the piping system. Then this hole allow to the fluid to flow, go into, yeah, yeah, to outside, yeah, to other system, maybe to outdoor system, yeah. Before we release to the outdoor, then they create the reflected silencer. So we go to car muffler. Is it reactive silencer or obstructive silencer or both? So actually, this one already answered in previous slide explanation. So you can uh, rewind my video to answer this question. Yeah. So I don't want to answer here. So you please find by yourself. Yeah. Okay, this graph is shown about sound power to frequency, yeah, or hertz. So frequency will be measured by unit of hertz. Yeah. So we have three types. Yeah. Silencer here. So the blue one without silencer condition. Sorry, this one is noise, without the silencer, and then the green one is expansion silencer, and then the orange one is combined expansion with the absorption silencer. So when we combine two system, maybe we'll perform good in the absorption, noise absorption. Yeah. So in the building, they try to also absorb the noise by the unique construction, yeah, and nearest to the south, yeah. Maybe you can see from the left figure is from the highway they try to build, yeah, because nearest to the this position is maybe nearest to the building. The building have equipment, yeah, maybe the office, maybe the condo, for the living. So they try to develop nearest to the highway by noise barrier. So noise barrier will absorb the vibration, yeah, from the highway. Not only from the highway, maybe uh, no, maybe not nearest to the only from the highway directly, maybe just behind or beside, yeah, of the highway. Maybe you can see like this, yeah? So the barrier will absorb the vibration or noise, yeah, from the highway. I think this one, the right side also described about the highway, because we can see the signboard here, and then the sound from the noise from the highway will be absorbed by this structure. So back to the text, yeah, noise barrier. A noise barrier, also called the sound wall, sound berm, sound barrier, or acoustical barrier, is an exterior structure designed to protect inhabitants of sensitive land use area from noise pollution. So actually, this noise barrier is created to absorb the noise, yeah, because noise is considered also as pollution, not only for the emission. The pollution also can be from the noise. Noise barrier, a material provide a barrier to the incident sound energy when it reduces the amount of sound energy that is transmitted through the material. So back to lecture 4, yeah, before the lecture 5, yeah. we already talking about the uh, incident sound energy. So coming sound, yeah, we can call this one is a coming sound, and then to will be impact to the solid, yeah, solid, and then the reaction of solid, yeah, we call the transmitted, yeah, and reflected. So we hope, yeah, noise barrier we can transmitted, yeah, to the material, and then will be absorbed, yeah, by reducing the frequency. So that's why we try to do create the noise barrier structure. We hope that we can absorb by transmitted by maybe transmitted will be reduced, yeah, compared to the without noise barrier structure. There are a number of factors that affect the amount of sound transmitted through the wall, including the type and thickness of material, frequency of the sound, quality of the construction. So back to the uh, lecture 4, yeah, we hope, yeah, the thickness also, yeah, type of the material itself, yeah, so can reduce uh, the noise barrier. So this one is actually the innovation, yeah, how we try to uh, absorb noise pollution in the maybe like metropolitan city, yeah, country, yeah, they have much of the industry, and then much activity of machine, yeah. So we hope this one is under uh, maybe government, yeah, government in reducing, yeah, government plan, yeah, in reducing the pollution, yeah. It's not only talking about the emission pollution, yeah, but also we in the future maybe the government should be think about this, yeah, to consider to how to absorb the noise pollution. Noise barrier materials still a noise barrier, a material that are dense, such as a masonry block or a wall board, yeah, or stiff such as a glass, are generally better at reducing transmitted sound than material that are lightweight or flexible. So maybe in the future, we try to create a smart material, so in the performance still have a good in the absorbing, yeah, for noise pollution, but for smart material, so we think we come out with also with a uh, maybe lightweight, yeah, performance, and then maybe have a good life, long life for the application. So maybe for maintenance, also we consider can be a low cost, yeah, and then also flexible, yeah. So not only uh, lightweight, yeah, because in the application sometimes we have a space issue, and then this material can solve, yeah, the space issue because of maybe need to flexible of material, yeah, and geometry also, yeah, because the flexible can have a capable, yeah, to uh, what tolerate in the difficult of geometry, yeah. And then finally, the ability of material to reduce transmitted sound depend on the frequency. High frequency sound is more easy reduced than low frequency sound, yeah. So this one also we hope, yeah, we need to implement in the high frequency of the pollution, yeah. Still, noise barrier are the most effective method of mitigating railway and industrial noise sources, other than cessation of the source activity or use of the source control. Yeah, And then the transmission loss is defined as the ratio between the sound power incident to the muffler and the transmitted sound power for the case that there is a reflection free termination on the downstream side. So still we use similar calculation, yeah, to calculate the uh, sound transmission. Yeah, I told you this one already learned in the lecture 3, yeah, and then you can see back the previous from the previous class, and then you can understand this one formula. I told you same thing like the before. Okay, this one is some application, yeah, in the engineering of the uh, absorbing, yeah, you can using the maybe around electric power, transmitted electric power, they have a transform transistor, a big transistor that have a sound, a big sound, and then they try to absorb, yeah, that noise, yeah, and then they create the one barrier around there, and then they try to absorb. Uh, so the engineer hope the sound cannot be transmitted to the uh, residents, around the industry. Yeah. So in the HVAC system also they have the envelope, yeah, the barrier structure. Yeah. Maybe this one structure is a rooftop of the HVAC system. Yeah. So they have the package of the HVAC system, and then also they develop the barrier to absorb the noise. Yeah. Okay, that's all for today. So please uh, fulfill the quiz, yeah, after this quiz. This quiz will be considered for your attendance. Okay, that's all for today for lecture 5. See you again next topic. Yeah. Assalamualaikum and good day.